Hey, ladies and gentlemen, today we're going to talk about finding a regression model using tables and exponential functions. So this is actually a really similar process as it was for the linear functions that we did first semester, as well as our quadratic functions that we looked at second semester. So it's kind of really similar. So I'm going to go through how to do it on Desmos. Then I'll create a separate video for the TI-83 or 84 calculator if you'd rather use that. And then written directions will be attached to tomorrow's activity for you so that you don't have to necessarily rewatch the videos in order to have the steps in front of you. So in order to do this in Desmos, we're going to hit the plus button and we're going to put in a table, and it automatically defaults to X1 and Y1. So we've got 1, 2, 4, 1, 2, 4, I think 5, and then 6, 9. And I'm going to put in my Y values that go with that. So we've got 2, 5, 10, 2, 5, 10, 15, and then 20 and 38. The cool thing with doing this in Desmos is that it will show you your scatter plot. So you can kind of see that it does look like an exponential function. So your exponential function is a good model for this one. Next, you're going to type in your generic exponential function equation. Instead of just using x and y, we're going to use x1 and y1 since that's what our table is labeled as. So we have y1, and I'm on my computer or on your Chromebook, you can hit y and then the 1, and it automatically subscripts it. My little approximate symbol is next to my 1 button on my keyboard. And if you, I can show you in a minute here, if you need to use your keyboard in the calculator, I can show you where that is. So y1 is similar to, or is approximately a times b to the x1. It'll give you your r-squared values that we did talk about way back when we did linear and the quadratic regression. For our class, so we do want this to be into log mode so that it calculates it the same as it would on the graphing calculator. Once you graph that in there, again, it's kind of neat here in Desmos. You can see the line or the curve automatically. And it hits most of those. It's pretty close. Remember, your r-squared value or your r value, closer to 1 it is, the better it is. So my parameters are 2.09 and then 1.42. So you just need to then take out the a in the equation, put in the 2.09 or the 2.1, and then take out the b and put in the 1.4. I'm going to round to 1 decimal place. The only thing I'm big on is just don't round to the nearest whole number if you're not told to. So here, I'm going to put this in. A couple different ways that you can do this. So y equals and 2.1 times, or we can put parentheses 1.4, and then I do control period to get my exponent, and then just put in an x, control period to get it out of the exponent. So there's our model for this table. Looking at number 2, I've got another table, but we have a couple questions. So I have a couple boxes here. We're going to put our model here and then our answer to the question here. So here we're talking about years. Whenever we deal with years with a regression, we don't ever have the year itself. Your x value is always the number of years since a certain time. So this table represents the number of years since 1995. So I'm going to go up here. You can do one of two things. You can actually X this out, or you could just go ahead and keep the table and just change the numbers. Just make sure you're careful when you do that. So we're going to go from 0 to 6. So I'm going to go ahead and do 0, 1, 2, 3, 4, 5, 6. And then I'm going to just kind of get rid of all those. I just arrowed down instead of hitting enter. Then we have 247. Now I can hit enter since it's already there. 372. 550. 842. 1221. 1915, and last but not least, 2786. Since I have everything still here, this was adjusting as we went. I can, like I said, scroll out and you can see your points, and you can see that this is an exponential function and it matches up pretty well. Your R values are really close to 1, so it's a good model. So here our A is now 246.9 and the B is going to round to 1.5. So I'm going to pop that in here. Y equals, actually another way if you want to, you can go up and do insert equation. You can do Y equals 246.9. Oops, put parentheses there. 1.5. And then if you do shift 6, this will pop it up into the exponent for you, and you just can put your x there. Alrighty. Now we're going to use this model to figure out what is the population going to be in approximately 2003. So we need to kind of figure out how many years is 1990 or is 2003 from 1995. So I can kind of go down here and use this calculator. We can do 2003 minus 1995, and that gets us 8 years. So I'm going to pop into my calculator 246.9 times 1.5, control period, and then put in an 8. And I'm going to do that. I can just X that out and do it underneath there. So 246.9 times 1.5, raise that to the 8th power, and that gives us 6327.77. Or 0.78. Officially, probably should have rounded that to the nearest whole number, but we are just looking for approximation. So rounding to the nearest whole number would be 6,328. That would work. So that's it. That's regression in a nutshell using Desmos. It's not so bad. And then you just substitute in. So this is very similar to what we were doing last week. It's just this week, we have to put our data into the table and get the regression out of the calculator. But as far as substituting in and everything, it's exactly the same. So if you have any questions, please message me. And again, a hard copy of this will be attached to tomorrow's assignment. Have a good one.